Section 10.4, find probabilities of disjoint and overlapping events. When you consider all the outcomes for either of two events, A and B, you form the union of A and B. When you consider only the outcomes shared by both A and B, then you form the intersection of A and B. The union or intersection of two events is called a compound event. To find the probability of A or B, you first have to consider what outcomes, if any, are in the intersection of A and B. Two events are overlapping if they have one or more outcomes in common. Two events are disjoint if they have no outcomes in common. So if we have any two events, A and B, then to find the probability A or B, we do the probability of A plus the probability of B minus the probability of A and B. So any events that are in both A and B, we have to subtract because we've added them in twice. With A, we add them with B, so we're going to subtract it off so we don't count it twice. However, if A and B are disjoint events, then to find the probability of A or B, we're going to find just the probability of A plus the probability of B. We don't have to worry about subtracting this off because there are no events in common, so there is no probability A and B. It's going to be 0. So first example we're looking at is with disjoint events. So we have a 6-sided die is rolled, and we want to know the probability that the number rolled is less than 3 or greater than 5. So we're going to follow the disjoint event ones because they don't share any outcomes in common. So we have the probability less than 3 or greater than 5 is the probability of less than 3 plus the probability of greater than 5. So if we rolled a 6-sided number cube or a die, less than 3 would be a 1 or a 2. So the probability of rolling a 1 or a 2, there's 2 choices out of a total of 6. The probability of getting a number greater than 5, we just have 6. 6 is the only number greater than 5. So we have one choice, one chance of getting that out of 6. 2 6 plus 1 6 is going to be 3 6, and that reduces to 1/2. So our next example is our multiple choice. So we, again, have a 6-sided die rolled, and we want to know the probability of rolling a number greater than 4 or even. So probability greater than 4 or even. So we need to figure out if we have overlapping events or disjoint events. Numbers greater than 4 would be 5 and 6. Our even numbers are going to be 2, 4, and 6. So you can see they have one value that overlaps. So we're going to have to do probability greater than 4, with overlapping events here, plus the probability even, minus the probability greater than 4 and even. So the probability greater than 4, we have 2 numbers greater than 4. So 2 out of 6 is our probability there. Probability that is even, we have 3 numbers that are even out of 6. And then the probability that is greater than 4 and even, there's one number that is in both of those. So we're going to subtract off 1/6. 2 plus 3 is 5, minus 1 is 4. So this simplifies to 4/6. And 4/6 we can reduce to 2/3. So looking at our answer choices, the answer is going to be C. Okay, so in our next example, we're going to be using a formula to find the probability of A and B. So of 100 students surveyed, 92 own either a car or a computer. Also, 65 own cars and 82 own computers. What is the probability that a randomly selected student owns both a car and a computer? So we know that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So what we're going to do here is we're going to solve this for probability A and B first. So I'm going to add probability of A and B to both sides, just like I would with numbers. Okay, so after I add it to both sides, that's what I get. And now I'm going to subtract probability of A or B. So now I have it solved for that. You could also plug the numbers in first and then do that, rearrange it. So now I have probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. So now I'm going to plug in the information that I know. So I know that the probability A, which we could say is own a car, would be 65 out of 100. The probability that own computers is 82 students out of 100. And the probability they own a car or a computer is 92 students out of 100. So then I'll add these 65 hundredths plus 82 hundredths is 147 over 100 minus 92 over 100 is 55 over 100, which we can also write as 0.55, or we could say 55%. You could also reduce the fraction and leave it in terms of that. Okay, so the event A bar is called the complement of A, and it consists of all outcomes that are not in A. The probability of the complement of A is 1 minus the probability of A. So if you know the probability of A, you can subtract it from 1 to find the complement. So a card is drawn from a standard deck of 52 cards. We want to find the probability of each event. So the card is not a 7. So first thing we're going to do is let's find the probability that it is a 7. In his deck of cards, there are going to be 4 7s out of 52 cards. So the probability that it's not 7 is 1 minus the probability that it's a 7. So 1 minus 4 over 52, which is equal to 52 over 52, getting common denominators, minus 4 over 52, which is equal to 48 over 52. And then we can go ahead and reduce that to 12 over 13. You can also get a decimal. Okay, and then we have the card is not a red face card. Okay, so now first we're going to find out what's the probability that it is a red face card. So your face cards in the deck, you have your Jack, Queen, and King. So you have 3 face cards in every suit, and there's 2 red suits. So the probability that it's a face card is 6 out of 52. So the probability that it's not a face card is going to be not red face card. 1 minus 6 over 52. Again, we're going to get common denominator, so we're going to rewrite 1 as 52 over 52, and we're going to subtract 6 over 52. So we get 46 out of 52, or 23 out of 26 if we reduce it, and then you can also put it as a decimal. I got 0.885 as a decimal. Okay, and the last example is using a complement in real life. So there are 10 people at a dinner party, and we want to find the probability that at least 2 people have the same birthday. So the total ways for birthdays is 365 to the 10th, because there's 10 people. So the probability that there's at least 2 the same is equal to 1 minus the probability that none are the same. Okay, so to find the probability that none are the same, Our total outcomes is going to be 365 to the 10th. And what happens is the very first person has 365 possibilities for that first birthday. Then the next person, there'll be 364 possibilities for their birthday. And then 363, 362, 361, 360, 359, 358, 357, and 356. Got a little small there, but I'm trying to fit it all in. So then to find the probability that at least two the same, is going to be 1 minus this mess. And then you can go ahead and enter this on your calculator. You may want to just put this in here just as extra on the calculator just to make sure you do this correctly. Or you could go ahead and calculate this and do 1 minus second answer. I got approximately 0.117 for my answer.